Hello, everyone, and thank you for joining us for the second Data Orchestration Summit. It's awesome to see so many people from all around the world joining in this celebration of data orchestration. I'm Calvin, and I'm joined today by my colleague Bin, and we're going to share with you the hottest use cases for Alluxio and the future direction we anticipate the project going. Let's get started. First, let's have a quick refresher on Alluxio. Alluxio is a solution for data orchestration for analytics and AI in the cloud. The key concept of data orchestration is to seamlessly allow compute and storage to work together without having to tightly couple them, or in Alluxio case, even make them aware of one another. Alluxio as a data orchestration solution is available on all major clouds and can also be deployed on-prem on bare metal or Kubernetes. Perhaps more important than what Alluxio is how Alluxio is being used and the benefits it provides. This presentation is divided into three portions. First, we will talk about use cases from an architecture and workload perspective. The goal of this section is to provide concrete examples that you'll be able to map to deployments that you're currently working on or have seen in the past. The next section is around the future directions we see the project going. This is always exciting because of the huge amount of support we get from the community. And finally, Bin will share some of the awesome community collaborations that have happened or are ongoing. These collaborations help steer the project in the future directions. First, let's talk about use cases. A huge number of companies leverage Alluxio, and they all leverage Alluxio in one or more of several high-level architectures I'm going to present. Try and keep these in mind throughout the summit. There are so many awesome data orchestration talks to come, and many of them will be very similar to one or several of these general use cases. There are two kinds of single cloud or on-prem use cases. These are architectures for simpler data analytics and AI deployments. As organizations and the data platform grows, you may be wishing to be able to return to one of these architectures. The first use case is running Alluxio between compute and cloud storage. You can think of a stack like TensorFlow on Alluxio on top of S3. Of course, TensorFlow can be replaced or joined by any other compute, such as Presto or Spark. And similarly, S3 could be Azure or GCS. The second use case is the same architecture, but on-prem instead of in cloud. Here, we see similar compute used, but users want to use on-prem object stores instead. These traditionally are not as performant and require more tuning than their cloud storage counterparts. So we see Alluxio sometimes providing a 0 to 1 benefit. The workload just simply wouldn't work without Alluxio in the picture. Let's take a closer look at the first use case on cloud. The biggest challenge is the mismatch between the data access required from compute frameworks and what the cloud storage can provide. We see this in performance variation and long-tail latencies, making it very difficult to provide SLAs. In addition, metadata operations are at a premium. In many cases, it literally costs money for each request. Finally, one of the biggest benefits of being in the cloud is to be able to use ephemeral instances on demand. But this also makes many of the existing solutions to these problems invalid. As a data orchestration framework, Alluxio is able to address these challenges in an architecturally sound manner. When deploying Alluxio with compute, users see significant performance gains and cost savings. The Alluxio metadata service intercepts metadata operations which would otherwise cost money and potentially have high latency. In addition, cache management techniques like preloading allow for consistent performance, especially if the Alluxio cluster has nodes which are not tied to the ephemeral compute cluster. If you're interested in this use case, there are a bunch of presentations which go into details, such as the ones from Data Sapiens and Electronic Arts later today. Now let's shift over to the on-prem version for those who haven't moved to the cloud. The challenges here are similar. The performance, both in terms of I/O throughput as well as metadata operations, suffer due to the storage used. In addition, the storage often is less compatible than the big name cloud object stores. In many cases, compute frameworks need to use less optimal connectors or even use a connector originally designed for another object storage in order to access their on-prem object store. Alluxio can help performance-wise even for HDFS storage, but really shines here as a solution for enabling object stores. Users do not need to go through a tough migration process for big data and AI workloads when trying to onboard to a cheaper storage. The applications can be seamlessly onboarded onto Alluxio, and the underlying storage then becomes flexible. Admins can migrate workloads at their own pace. For users that need on-prem deployments, Alluxio is becoming very popular as they look to reduce storage costs. For example, Alluxio first started being used at a top banking institution because they needed something to make their object storage usable for the numerous data applications they had already built for Hadoop. Now let's get into the more complex data orchestration use cases. These are often found at larger organizations due to the number of teams involved on using the data platform. We have two hybrid type use cases. You can think of them as mirrors of one another. First, we have bursting to the cloud, where the ground truth of data lives on-prem in a storage like Minio, Ceph, or HDFS. To support compute demand, users often look to the cloud and over time want to migrate the workload completely to cloud. The reverse is when the data has been moved to the cloud, but users still need to use on-prem resources to work on the data. This is more common for AI workloads where hardware is at a higher premium. The last use case is for multi-data center and cloud environments. Multi-geo deployments, whenever I've heard of them, have never been easy. However, data orchestration is definitely one tool which makes approaching these deployments easier. Let's take a closer look at the hybrid cloud bursting use case. While a great idea for cloud resources, bursting and eventually migrating to the cloud is not easy. In the initial phases, reading data from on-prem causes performance issues and potentially impacts the on-prem cluster itself. The solution of making a copy of the data in the cloud is also fraught with issues, such as keeping copies in sync and ensuring all relevant data is copied over. For example, what happens when a data set gets updated outside of the usual pipeline, like if some data comes in late and the data set needs to be regenerated? And of course, even if the data does end up being copied over to a storage like S3, we actually end up in the first use case again, where we have a compute interacting with cloud object storage. It's really rare to be able to see the performance of a cloud object storage meet that of co-located storage on-prem, especially on the first try. And when the performance isn't good enough, it makes it very hard to progress further in the project. One of the best use cases for Alluxio is hybrid cloud bursting. We call this zero copy burst. The Alluxio layer provides performance similar to what was previously available on-prem and doesn't need manual data migration. This enables projects to hit the ground running and not be mired in data movement or performance issues. Metadata and data caching keep the on-prem storage actually offloaded. In many cases, this is key because storage often is provisioned for only as much compute as can fit on-prem. If you add in a bunch of cloud resources, soon the bottleneck will be put back onto the on-prem storage. Aside from performance, the zero copy aspect is a huge benefit. The architecture with a data orchestration framework allows for the right thing in terms of data movement to happen naturally. No new copies of the data are made, and no one needs to keep track of when a file gets updated outside of the normal pipelines. Finally, because Alluxio can connect to multiple storages, it's a natural fit to use as a data management plane for gradually migrating data to cloud storage. To the applications using Alluxio, the shift in storage is completely transparent. Walmart was able to leverage Alluxio for this exact use case. They needed more capacity for data analytics and wanted to use Presto in the cloud to offload workloads that were previously on Hive on-prem. A big requirement for them was to avoid making copies in the cloud, and zero copy burst was perfect for that. The performance gains from switching to Presto as well as Alluxio caching were just both bonuses. Now let's take a look at the reverse case. After data is in cloud, it's tough to get it back into a private data center. For starters, it usually comes with a bill. Taking data into the cloud is pretty easy, but getting it back out is hard, especially if you want to keep the source of truth in the cloud. Each time you pull the data, you'll have to do a new data transfer, and that quickly adds up in costs. In addition, the performance hit of pulling the data over the network is usually a deal breaker for performance-sensitive applications. Alluxio can act as a hybrid cloud storage gateway when deployed with compute on-prem. Because Alluxio is caching the data, a large amount of the cost associated with network egress costs is saved. In addition, we are able to achieve good performance due to that caching. Don't miss the talk tomorrow where the folks at Comcast will share how Alluxio is used in this fashion. All right, we've made it to the final archetype of use cases for data orchestration, the multi-data center use case. You can think of this as a combination of the previous use cases, and naturally this combination comes with the combined challenges of those. A common goal of multi-data center deployments is to be able to utilize multiple data centers as one logical data center, but have all of the benefits of geo-separation, like performance as well as fault tolerance. Getting to this state requires data to be synced, which requires careful and often manual data movement. Another multi-data center architecture is to have one central data storage cluster and have it surrounded by many different satellite compute clusters. This scales compute, but only to the extent to which the storage cluster then becomes the bottleneck or becomes overloaded. With Alluxio and data orchestration, the multi-data center use case becomes more manageable. The data management aspect allows for one logical copy of data and virtualized copies to be created transparently. The data caching aspect eliminates the performance bottlenecks of relying on remote data and allows the central storage cluster to be offloaded in the case of satellite clusters. The data platform then gains the ability to scale out compute without impacting storage. This allows data platforms to attain a very often sought after goal of being self-service. So whenever you have a new customer on board to your data platform, it doesn't impact any of the other users on your data platform. Multi-data center deployments are the hardest to grasp conceptually, so I wanted to share a concrete example. At Adobe, they needed to offload their central cluster as their data analytics workloads grew exponentially. They did this by adding satellite clusters, which read from their central storage cluster. But of course, they ran into several challenges that we mentioned before, such as overloading their storage cluster and the slow cross-data center performance they saw, which is why they decided to explore data orchestration with Alluxio. After adding Alluxio, they saw performance boosts of about 3 times, which let them hit the acceptable performance requirements. In addition, they reduced their load on their central data cluster to avoid overloading it even further. With this architecture, they were able to achieve the goal of a self-service data platform. If you want to hear another great example, make sure to attend the Rakuten presentation tomorrow. I've gone over 5 general use cases, and some of you may already be seeing a pattern. To get the best of both worlds, use a data orchestration framework like Alluxio. It's useful when the data lake is remote, overloaded, has variable latency or low performance, or doesn't support some of the same semantics, or really any of the host of several possible issues. I specifically mentioned data analytics in the last slide. I'll be talking about AI and machine learning workloads in this section. While Alluxio is a good fit for both, I would say OLAP data analytics are a tried and true fit where we understand the set of benefits that are being provided. We've also seen good results so far in AI workloads, but it's also somewhat more exciting because we're still discovering what their full potential is. The story for AI and ML workloads is very similar to data analytics. They both run on data lakes. Machine learning workloads have different characteristics, but the core of the problem is the same. The storage and compute are mismatched. Some examples of characteristics are access pattern, the file layout of the dataset, the preferred API, and the workload regularity. These are exciting because in some cases, the gap is even bigger than it was for the OLAP data workloads. AI workloads tend to repeatedly access a fixed dataset, which is a great use case for Alluxio's caching. Small files mean that the metadata overhead is going to be even more pronounced when using something like an object store. The need for a POSIX API is something that's even further than what's provided by the object stores. Finally, the predictable access of a machine learning algorithm makes data management even more powerful. Generally, users train on a fixed dataset, whereas a data analyst might decide to query a new table out of the blue. I want to mention that a huge part of this is only possible because the Alluxio community is awesome in using the software and pushing the boundaries. I'm going to hand it off to Bin, who is truly a pillar of the Alluxio community, to share in more detail the cool stuff that's been going on in the community.
Hi, everyone. I'm Bin Fan. Like Calvin, I'm also the founding engineer of Luxio. I am currently leading the open source community efforts in Luxio. In the second part of this talk, I hope to give you an overview of Alluxio in terms of its status of the open source community. We recently released 2.4.1 in Alluxio in November, with 1,090 contributors in total on GitHub by this release, compared to 2.1.0, which was released in last year's our first data orchestration summit, which is about 1 year ago. There are 1,000 more pull requests merged into the latest release. Since last year, more users are joining our community through Slack, where many users asking questions and providing us feedback with our core developers. Today, we have more than 5,000 strong users in total in the Slack channel. In the next slide, this figure shows you the fast growth of the community members on Slack since last year. I'm very active on the Slack channel, so if you want to discuss with me about Luxio, welcome to join the Slack channel as shown on the top. As the user base is quickly growing, we have also seen Alluxio had been used by in a really significant way by industry leaders. For example, one of the top cell phone provider is currently running Alluxio at 3,000 nodes in a single cluster to accelerate the data analytics using Spark or Hive. Alluxio provides great performance efficiency here because its storage in this architecture is decoupled with its computation. So Alluxio can cache the data and provides a lot of speed up in this case. Another example is in the top social network company, where Alluxio data caching is also used to speed up queries at 10,000 Presto nodes, with more than 10 petabytes data managed in Luxio space. Alluxio becomes on the critical path on its latency sensitive data queries for many data applications. As users are using Alluxio both in breadth and in depth, we have seen communities organically organized to group together and make faster progress by working with each other. For example, the core maintainers, including me, are working closely with engineers from Microsoft and Alibaba and graduate students and researchers from Nanjing University to investigate how to run deep learning framework and workloads on Alluxio more efficiently. Since late spring, we have been meeting regularly to discuss issues, features, bugs, optimizations. Particularly, together we have created a new implementation of Fuse integration based on JNI, which is Java native interface, for better scalability and stability. We have also been constantly optimizing Alluxio for workloads, reading a massive amount of small files, as well as tuning the performance for RPCs. To follow the similar pattern, we are also leading a new effort to work in a special interest group running Presto on Luxio, and with the new data structure service introduced in Alluxio. We have kicked off the community sync on this direction with engineers from Tencent and Robinhood joining. If you are interested in either directions or you have some other ideas, feel free to talk to me or contact me on Slack. Another important change we are making here is to speed up the release cadence. In the past few years, Alluxio release cadence is about one new release each quarter, not counting these patch releases. We are experimenting a new release schedule to push out a new release every other week, starting this month. We hope to use a faster release cadence to respond to our users and community faster, with bug fixes and new features delivered in a sooner way. So this is my last slide. I hope you have seen a rapid growth of this community, and we are becoming a very important player in the data and AI ecosystem. I sincerely welcome you to join us either on Slack or join our online meetup group, or follow our WeChat public account. And this concludes my talk, and hope you enjoy the conference. Thank you.